Okay, so this is week 4, and this week we only have one video. Before I start solving the problems, I'd like to go over these concepts here, which I've written to the right. Let's first look at concept I. We're going to use these rules when we solve these problems. We have I, or 1, if the absolute value of x is greater than c, then this means that x is less than minus c, or x is greater than c. And this works if c is any positive number. And so if we were also to replace this here with the equal sign, then you'd also have to place equal signs here and here. Now rule 2, if x absolute value is less than c, then x is less than c, and x is greater than minus c. And for short, you can write this like here, like I've written below. This means x is greater than minus c, less than c. So we're going to use these when we solve the problems. So let's start with problem 1, which has directions to solve. And the equation we're given is absolute value of u plus 9 is greater than or equal to 20. Our first step needs to be to isolate the absolute value. So I'm going to subtract the 9 on both sides. Subtract 9 on the left and the right. And so the 9 and the minus 9 cancel, since 9 minus 9 is 0. And our new equation can be rewritten as the absolute value of u is greater than or equal to 20 minus 9, which is 11. Now what we have is the setup of problem, or fact 1, where the value of c is 11, and instead of an x, we have a u. So we just apply this idea. So instead of x, you write a u. Instead of a c, you write 11. So we have u is less than minus 11, or u is greater than, I'm sorry, this should be an equals here, or equal to 11. We get this just from applying rule 1 here. And so our solution is this right here. Now let's look at problem 2. So we want to solve, and we're given the equation 2 absolute value x is less than or equal to 16. Like problem 1, we want to isolate the absolute value, so we need to get rid of the 2. To get rid of the 2, we just divide both sides by 2. So I divide the left by 2, and I divide the right by 2. So we have here on the left a 2 over 2, which is just a 1, so you can just cross these out and ignore them. So our simplified version of this equation is on the left we have absolute value x, and then less than or equals to 16 over 2 is 8. And so what we have now is situation 2, where we have x less than or equal to c. So our solution is just going to be of this form: x greater than or equal to minus c, less than or equal to c. We must add the equal sign under here since we have the equal sign x less than or equal to 8. So our solution is just going to be of this form. So we write x less than or equal to 8, then greater than or equal to minus 8. And this forms our solution, just by applying rule 2. Okay, let's move on. Problem 3, the directions are to solve and graph the solution. And we have the equation, absolute value of 4w minus 12 is greater than 16. So first we need to solve. So to solve, you can see that we already have the absolute value on one side. So that's isolated, that's fine. We just need to know which rule to use. So notice that we have a greater than here. So we're going to apply rule 1 In this case, we have the C is equal to 16. And instead of an X, we have 4W minus 12. So what we'll have is 4W minus 12 is less than a minus 16, or 4W minus 12 is greater than 16 by applying rule 1. So let's just write this out. We have 4W minus 12 is less than a minus 16, or 4W minus 12 is greater than 16. And so to solve this, we just need to solve each of these individual inequalities. So let's solve the one on the left. 4W minus 12 is less than minus 16. So I'm going to add a 12 to both sides, so we can isolate the 4W. So here we have the 12 and the minus 12 cancel to 0. And our new equation is 4W is less than, and the minus 16 plus 12 is a minus 4. Now to solve for W, we just divide both sides by 4. So I divide by 4 on the left, and I divide by 4 on the right. And the 4 over 4 is 1, so you can just ignore these. So we get a W on the left. And on the right, you have minus 4 over 4, which is a minus 1. And let's keep the ors here. Now let's look at the one on the right. So we go through the same process. We add 12 on both sides. And the minus 12 and the 12 cancel. So we just have a 4W on the left. Then greater than. And 16 plus 12 is 28. And so now to solve, you just divide both sides by 4. So we divide by 4 and divide by 4. The 4 over 4 is a 1, so you can just get rid of the 4's. So we have W is greater than, and 28 over 4 is equal to 7. So here's our solution, is W is less than minus 1, and W is greater than 7. But the other part to this problem is we want to graph. So let's draw a graph here. And so let's just do it piece by piece. So let's first note that when mathematics, what OR means is you take both. So what this means is we take all the numbers on the number line less than minus 1, combined with all the numbers greater than 7. So let's do each piece separately. So we first look at W less than minus 1. So for example, minus 1, let's say, is right here. So since it's a strict less than and no equals, we use a circle, not a dot. Because it's W less than minus 1, we must shade to the left. So we're going to shade to the left here. So this here, with the circle at the minus 1 and the shade to the left, represents the equation or solution W less than minus 1. Now we want to look at W greater than 7. So 7, it's going to be a little bit to the right of minus 1. So for example, right here. Because it's strictly greater than, no equals, we put a circle here. And because it's greater, we shade to the right. So greater means shade to the right. And so what we have as a result is a graph with a circle at 7 and minus 1, shading to the left of minus 1 and to the right of 7. So we have our solution here, and we have our graph here. Let's look at one more example. Example 4 is to solve and graph the solution, just like example 3. So let's go through the steps. First, let's note that the absolute value has been isolated. And so it's in the form, let's look at page 1, of number 2, where we have an equal sign, less than or equal. And in this case, instead of an x, we have the minus 21 minus 6x. And instead of a c, we have a 9. So this means our solution is going to be of this form, with the x replaced by the minus 21 minus 6x and the c with a 9. So let's write that down. So we have minus 21 minus 6x is less than or equal to 9 and is greater than or equal to minus 9. This is just applying rule 2 from page 1. Now we want to get rid of this minus 21. So on each part of the inequality, I'm going to add a 21. So on the left, right, and the middle. So let's take a minus 9 plus 21. That's a 12. So on the left, we have 12. And then less than or equals. The 21, so you can cancel the plus and minus. So you just have a minus 6x. And then less than or equals. And then 9 plus 21 is 30. So now here's the step where we must be careful. To solve this for x, we must divide each portion by a minus 6. But we must remember that if you divide the equality by a negative, you must switch the direction of the sign. So in my next step, I'm going to divide each portion by a negative 6, and we're going to switch the direction of the sign. So let's divide by negative 6 in the middle, divide by negative 6 in the right, and then divide by negative 6. And I'm going to put this sign here to denote that I'm going to switch the direction, like an arrow here. So let's see what this is. So first of all, you take 12 divided by minus 6. That's equal to minus 2. And now we must switch the direction of the sign. So it was less than or equal before. Now the open side must be facing to the left. So we have this sign, greater than or equal to. And then minus 6x over minus 6. Minus 6 over minus 6 is 1, so you can just get rid of them and we have an x. Now we must switch the next sign. So it was a less than here. Switch to the other direction, so it's greater than here. And then we take 30 over minus 6, and that's equal to a minus 5. And so here's our solution. We have that x is less than or equal to minus 2, greater than or equal to minus 5. So that's the first part. The second part is that we want to graph the solution. So we always start this off by we need to have a number line. And on this number line, we need to mark the numbers minus 2 and minus 5. So minus 2 will, let's say, somewhere right here. Minus 5 would be a little bit to the left. Now, do we put a circle or a dot at minus 2 and 5? So notice here the inequalities have an equal sign with them, which means we must place a dot at minus 5 and at minus 2. Now, what we want is everything less than minus 2. So above this, I'm going to we just mark off what is less than minus 2. So that's everything to the left. So you can think of it like being everything in this direction. So that's everything less than or equal to minus 2. Now we also want everything greater than or equal to minus 5. So down here, that's everything to the right of minus 5. So that's greater than or equal to minus 5. What this statement means, it's an and statement when you have something like this. What an and statement means is you can only take the portion that both have in common. So what do both of these red lines I drew have in common? So you notice that if it's to the left of minus 5, the bottom portion doesn't have that. If it's to the right of minus 2, then the top portion doesn't cross that. See, it doesn't go to the right. So this means the only portion shared by both of these lines is the place in between minus 5 and minus 2. So we must just shade in between the numbers. So this is our solution. We have minus 5, minus 2 with dots, and we shade just everything in between. So this is our graph. Okay, so let's move to the extra problems I picked. I picked 3 extra problems. Problem 1, with the star by it, I'd like you to solve for the attendance. This is the only attendance problem for this week. And the directions are to solve absolute value of u plus 13 is less than 19. And so you can just do your best. I'm not picky if someone makes mistakes or doesn't know what to do. I just wish that people try the problem. So if you try the problem, you get the attendance points, regardless of whether you get it right or not. But the problem 2 and 3, we will work through. So I'd like you to first try 2 and 3 on your own. And if you get stuck or want to check your answer, you can look at my solution I give in just a second here. So problem 2 is to solve absolute value of w minus 19 is greater than minus 7. And problem 3 is to graph the solution. Absolute value for w minus 6 is greater than or equal to 14. So you can go ahead and try number 2, and I will go ahead and write the solution down now. So first thing we want to do is to isolate the absolute value, which means we need to get rid of this minus 19. So I'm going to add a 19 to both sides. We have a minus 19 plus a 19 is 0, so you can cross these out. And our new equation is absolute value w is greater than minus 7 plus 19 is a 12. And so we have the equation absolute value w is greater than 12. So this is just like rule 1 from page 1 that I wrote down. And so using rule 1 with c is 12 and x is a w, we get w less than minus 12 or w greater than 12. So we have w less than minus 12 or w greater than 12. So let's look at problem 3. We want to graph the solution. Absolute value for w minus 6 is greater than or equal to 14. So again, we have the greater than or absolute value of x greater than or equal to c, where the x is the 4w minus 6 and the c is the 14. So applying the exact same rule we did here for number 2, we said the inside less than or equal to the minus of 14 and greater than or equal to the positive. So we have 4w minus 6 is less than or equal to minus 14, or 4w minus 6 is greater than or equal to 14. And so our next step is going to be to solve each of these. So let's solve the one on the right. We have 4w minus 6. I just want it to be a 4w. So I'm going to add 6 to both sides. The minus 6 and the 6 cancel. So now on the left, we have a 4w. And then less than or equal to. Then minus 14 plus 6 is a minus 8. And now to solve for w, since we have 4w less than or equal to minus 8, we just divide by 4. So I divide the left and right by 4. The 4 over 4 here cancels, so we just have a w. And it's less than or equal to minus 8 over 4, which is minus 2. So for our first solution, we have w less than or equal to minus 2. I'm going to place the ors here. Now we have on the right, 4w minus 6 is greater than or equal to 14. I'm going to add 6 to both sides. The minus and the positive 6 cancel. So simplified, we get 4w is greater than or equal to 14 plus 6 is 20. Now we divide by 4. So we have 4w over 4 on the left, they cancel. And so our simplified version is we have W is greater than or equal to 20 over 4, which is 5. So here's the first part is our solution. We have W less than or equal to minus 2, or W is greater than or equal to 5. And now the remaining part is to graph. So we make the number line. We mark the points minus 2 and 5 on the line. So minus 2 is going to be somewhere over here, for example. 5 is going to have to be to the right. Since it's less than or equal and greater than or equal, we must place a dot at these points instead of a circle. So I'm placing a dot at minus 2 and 5. And we want to mark everything less than or equal to minus 2. Less than means shade to the left. So I'm going to shade to the left here. And we also want to take everything greater than or equal to 5. Greater than means shade to the right. So we'd start at 5 and then shade to the right. And or means you take both. So it means you take both everything here to the left of minus 2 and to the right of 5, which means that this graph we've drawn is our solution. This ends the examples I've picked for today.